This is the lab for data acquisition or DAQ module calibration. First, open the VI and double-click on the DAQ assistant in the block diagram. Choose the Settings tab, and this is where you'll specify several parameters, such as the gauge factor being equal to 2, the gauge resistance being equal to 350, the initial voltage being equal to 0, and just set it to 0 for now, as LabVIEW will correct it later for you. The excitation voltage source to internal, the excitation voltage value in volts to 5, and the strain gauge configuration to a full bridge type 1 configuration. Once you set these, go up to Device and click that tab. Once you've clicked on the Device tab, click on Strain Calibration, and in this window, make sure you leave Offset Nulling checked and uncheck the Enable Shunt Calibration. Once you do that, click Next, and then click Measure and Calibrate. So when you get to this page, you'll click Measure and Calibrate. This will run. After it runs, you'll be given an error percentage. If your error is too high, above 50% for example, then check the parameters in your Settings tab. And if it's not high, for the example this one, we have a 0% error, then we're going to go ahead and click Finish. And when we click Finish, we'll see this calibration successful text pop up in the bottom left corner. So when you're done with that, just make sure you go back to the Settings tab, and you'll see that the initial voltage will have updated its number. This is going to be the proper initial voltage that you'll use in your report, and so just make sure you record that value here. The units will be volts, and also make sure you have an appropriate sampling rate. We'll say about 2000 Hertz. And also you acquire sufficient amount of data points. We'll say if we want 2 seconds of data, then we want 4001 samples to read. Once you do that, you're going to go down here, click OK, and then a window will pop up showing Building VI is being implemented. So when you go back to your VI, you're going to see something like this. This is going to be your front panel, and we need to make sure before we click Run that all of these are good to go first. So we want to make sure that we're looking at these blocks. Now B, C, and D are dimensions of the beam itself. They're measured in meters, and they're provided to you in the handout. So just make sure you have the corresponding numbers to the corresponding constants, and you should be good. For mass, these are measured in kilograms, and this mass should be the mass that you are putting on the loading point. So make sure if you put, for example, 550 grams, that you put 0.55 kilograms mass here, and then make sure you have the number of samples set to 4001 for 2 seconds of data at a sampling rate of about 2000 Hertz. Once these are all filled in, we're good to go. We click Run. Once you click Run, you're going to see these numbers populate down here. And we want to use, for these values, we want to use the mean, if they have the mean provided. And this mean E, mean lowercase e, this is going to be your strain. It's going to be unitless. And this mean capital E is going to be your Young's modulus of elasticity. It will be in either pascals, or it can be in gigapascals. The unit should be right next to it. And you have sigma, and that's going to be your stress, and that would be in pascals or gigapascals. So we're going to, after we have run the calibration, we run this, we're going to look at these values just to see if they kind of make sense. And the ones that's going to be dead giveaway is your mean E. So if you're looking at this and say, does it make sense for that material to have a Young's modulus of elasticity of this value? So you can compare it to other materials and say, does this make sense for this material to be have this E? If it does, then you're good to go. You have calibrated correctly. If not, if it doesn't make sense, then you might want to go back and restart the calibration phase over just to make sure there wasn't anything missed. And that's it. Once you do that, you have everything calibrated and you should be good to go.